Now I'll say so. Okay? So, this week, we need to do today's stuff, okay, which is going to be matrix operation type things. We're going to get us back into matrices in order for you to watch the flipped video tomorrow. So that's why we didn't tell you about the flipped video yesterday already. Okay? But so tonight you got to watch a flipped video for tomorrow's class. I'll post it online here within an hour. Okay? So you can start watching it, but you got to get through today's class so that you understand what a matrix is before you watch the video, or refresh your memory as to what a matrix is before you watch the video about multiplying matrices. Okay? So that's out there for you. There's also the solutions to Q3, this is. Okay? And then I'll entertain any questions on the Q3.
Yeah, that's
Just because there was work to be involved in it, you know. Anything? Change colors. Okay. So, we're learning the basics today, okay, of matrices. We're crawling before walking, before running a marathon tomorrow. Okay? So, a matrix is a rectangular arrangement of numbers organized into rows and columns. Okay? And it's named using a capital letter, and the individual numbers, the parts that make up a matrix, are called elements. So let's explore a 2x3 matrix. Okay? So I'm going to call it matrix A. Matrix A is a 2x3 matrix signified by the subscript after it here. This would be how many rows and this would be how many columns matrix A has. For most of us, we have an address. Some of us might have multiple addresses. 3 in this matrix has an address of row 1, column 1. So 3 lives at A11. -5 lives at A23. So it's in row 2, column 3. So each element has an address. Questions on the basic setup of a matrix. Matrix is the singular, matrice is the plural. Alright, here we go. Name the address of that element. What's the address of 6? Where does 6 live? D22. Because it's in matrix D. It's in row 2, column 2. If I changed it to there, now what would the address be? What do we got? D13, because we're in matrix D still, row 1, column 3. Okay. Addition and subtraction. The cool thing is that we can take our matrices and we can add and subtract them. However, there is one major condition that we have in order to add and subtract matrices. And that is that the matrices that are being added or subtracted must have equal dimensions. So your first check before every adding and subtracting problem is, are the matrices the same size? This first matrix here is a 2 by 2 matrix. It has 2 rows and 2 columns. The second matrix here is a 2 by 2 matrix. It also has 2 rows and 2 columns. It's the same size. Okay? So condition number 1 has been met. If condition 1 is not met, it is not possible. And you can't add a 2 by 3 matrix with a 5 by 7 matrix. You just can't do it. It's not possible. They have to be the same size. So condition 1 is met. After that, if condition 1 is met, then you simply add or subtract the corresponding elements. Okay? So the first row and the first column of the first matrix gets added to the first row and the first column of the second matrix. So 4 plus 2 is 6. The first row, second column element gets added to the first row, second column element. 0 plus 7 is 7. Second row, first column, gets added to second row, first column, -7. Second row, second column, added to second row, second column, -3. And that's your answer. Or that's your result, I should say. Okay? You try that one. Okay. So, first element, or first row, first column element, 3 minus -3 is, whoops, whoa, tap the brakes, is 6. -5 minus 0 is negative 5. 10 minus negative 2 is 12. And negative 4 minus 4 is negative 8. Agree? Good look or not? You have a confused look on your face. Good. Like I was pulling numbers out of thin air. Okay. One of the matrix type addition, subtraction, multiplication type matrix problems that are out there is one that looks like this, where it's going to ask you to find X or Y or Z or W or however many that you have. Okay? And you can do that using your matrix addition properties, if you will. Okay? Now, in all of these problems, this one we only have to find one variable, but you might have to find more variables elsewhere, okay, in another type of a problem. And there will usually be at least one control, is what I call it, okay? Meaning that negative 2 plus negative 3 is negative 5. Okay? Just to show you that it works out. Okay? So that in this particular case, then we also have 1 plus 6 equals 7, and we have negative 5 plus 4 is negative 1. So we have all of those that work out just to prove that the problem works out. Okay? But what we don't have is this one. X plus 7 equaling negative 2. And we need to just solve that one for x then. X plus 7 equals negative 2. I'm going to subtract 7 from both sides. So x here is equal to negative 9. When x is negative 9, that becomes a true matrix equation. Okay? And again, on your homework, I think you do a little more, and I don't want to say more complicated ones, but there's not just one to solve for. There's like 2 or 3 or sometimes 4. Okay? Scalar multiplication. Scalar multiplication takes a number out in front of our matrix, and we need to multiply our matrix by that real number. So we're going to multiply every single element by that number that's out in front. Okay? What does that remind you of? Distribution. Yeah, we're basically, what's happening here is we're taking this negative 3 and I'm distributing it into every single element inside the matrix. Okay? So negative 3 times positive 3 is negative 9. Negative 3 times negative 3 is positive 9. Negative 3 times 1 is negative 3. Negative 3 times negative 1 is positive 3. Whoa, what happened there? And that's my result. Okay. Now, we can kick that up a notch, and we can combine scalar multiplication with adding and subtracting of matrices, and then we get a problem that looks like this. So what I'd like you to do now is I would like you to try that problem. Now I write things out. So you might be able to do this math in your brain, and I probably could too, but I still like to write things out. So this would be first 8, 12, -4, and 20. Okay, a 2 by 2 matrix. Read left to right, top to bottom. 8, 12, -4, 20. Then minus 6, -4, 1, and 5. So that's going to be 8 minus 6 is 2. 12 minus -4 is 16. -4 minus 1 is -5. 20 minus 5 is 15. And that is my resulting matrix. Okay. Questions so far? I've been forgetting to ask. Try that one. So I do that multiplication first, and then that gives me 2 plus -6 is -4. -3 plus 14 is 11. 0 plus 2 is 2. 1 plus -4 is -3. So that would be my resulting matrix. But then it also asked me to find the element from row 1, column 2. And that element is 11. 11 is in row 1, column 2. Agree? One more. Okay. Find the necessary value of y to make this matrix equation true. Oh. Quick check. 3/4 times -4 is going to be -3 plus 3 is 0. So it is going to be a true matrix equation, provided we find a value for y. Okay. So that would be 3/4 times 2y plus -4 has got to be 5. So that's 3/2 y minus 4 equals 5. Add 4 to both sides. That's 3/2 y equals 9. Multiply by 2/3. That gives me y is 6. Yep. Agree? Y being 6. Okay. Now you you have enough information to not only do the Q4 homework, okay, which is in your packet, but you also have enough information now to watch the flipped video for tomorrow's class. Okay. Good times. Good times all around.